Before we go to the next example, I want to talk a little bit more about left and right hand limits. So in the last example, we were looking at the limit as x approaches some value a, and we took numbers that were less than a, and we looked at what happens if we sneak up on that value of x from the left, so values that are less than a. We took values that are less than a and put it into the function and to see what would happen as we get closer and closer to a from the left. Okay, so when we do a left-hand limit, we're taking values of x that are less than a and plugging them in and looking at what happens as we get closer and closer, looking what happens to the value of the function as we get closer and closer to that a value from the left. And we can do the same thing from the right. We can take values that are a little bit bigger than a and sneak up on the value of a and see what happens to the values of the function as we approach a from the right. Okay, so that's all we mean by left and right hand limits. Sometimes when you read these definitions, it sounds a little more complicated than they are. All right, so we have the left hand limit is when we take values of a that are a little bit less and we approach the value of a from the left, okay? Or we can approach it from the right, okay? Now, there's some notation here. When we write this out, the limit as x approaches a from the left, that's what the little minus superscript means, is that we're approaching from the left. I don't know what happens to my inking sometimes. From the left. Okay, so we're approaching from the left. So we're approaching from the negative side of the x-axis. Okay, that's why there's a superscript negative, right? Now, over here, we use a little plus to say that we're approaching a from the right. So we're approaching from the positive side of the axis, right? This is approaching from the positive side of the axis. This is approaching from the negative side of the axis. All right. So those are left and right hand limits. Now they could be equal to each other or maybe not. So like in this example that's drawn here, this function is, has a jump, right? There's a discontinuity, we say, at a, and so the limit from the left and limit from the right are not the same values. But now, if the two values when we approach from the left and the right are equal to each other, then we can just write that the limit as x approaches a is whatever that limit is. Just like when we did the limit as x approaches 2 of x squared, right? We were approaching 2 from the left, we approached 2 from the right, we get the same values, so we can just write the limit as x approaches 2 of x squared, right? Let me write that down. The limit as x approaches, I should probably scroll up a little bit, x approaches 2 of x squared is equal to 4, right? And we can say that because it doesn't matter if we approach from the left or the right. The limit as x approaches 2 from the left of x squared is equal to 4, and the limit as x approaches 2 from the right of x squared is also equal to 4. And if both of those things are true, right? It has to be and both are true, then we can just write the limit as x approaches 2 is equal to 4. All right, so let's go on to the next example here. All right, so here we just have a graph, and we're asked to find these values, okay? So the first one is just f of -2. All right, so we have this graph. Now, one thing you should know is that the convention is when we have an open circle, that means that we can get as close to that value as we want to, but we can't actually go there. All right, so if we look at -2, you can see if I go straight up, okay, we hit this open circle. So that value, that point is not actually included in the graph. It's actually this point. So when it's a solid circle, then that is the value of the function. Okay, so we can say that f of minus 2 is 4. Okay, right, because the solid circle is there. Now, the limit as x approaches 2 from the left, right, from the negative side of the, from the negative side of the axis. We're approaching from the left. That limit, as we get closer and closer and closer and closer to negative 2, the value of the function looks like it's getting closer and closer to positive 2. Okay? So we're just taking x values that are a little bit less than negative 2 and getting closer and closer to 2. As we approach negative 2, the value of the function approaches 2. Okay. Now, if we approach it from the right, so that's what this part C is saying. What's the value of f of x as we approach x from the right? Okay, so now we're approaching it from the right, and it looks like as we get closer and closer, as x gets closer and closer to negative 2, from the right, it's 4. The value is 4. Now, the next one is asking, what's the limit as x approaches 2 of f of x? So, like we said in that last little box up here, if the left and right hand limits are equal to each other, then the limit as x approaches that value exists. So in this case, we've got an issue, right? Because the left hand limit and the right hand limit are not equal to each other. So this limit does not exist, okay? So I'm going to write DNE. That means does not exist, okay? So, all right, so let's go down to 0. It looks like these next questions have to do with what happens as we approach 0. So f of 0, again, f of 0, here's 0 is at the origin. You can see we have this open circle at 0, 0. So that point, 0, 0, is not actually included in the graph. It's the solid circle that's included. So based on the graph, it's telling me that f of 0 is 2. Okay. Now, what happens if I follow the graph and I approach, whoops, the first one is approaching from the right. So let's go from the right first. All right, let's see what happens as I approach 0 from the right. Okay, so from the positive side of the axis. Then I can see that it looks like I'm approaching 0. The values of f, right? The values of f seem to be getting closer and closer to 0. If I don't actually go to 0, right? I'm just sneaking up on 0. So this looks like this right-hand limit is going to have a value of 0, right? Now, if I approach x equals 0 from the left, okay, from the negative side of the axis, then again, it looks like the values of f of x are approaching 0. All right. Now, those left and right-hand limits are equal to each other, right? So I can say that the limit as x approaches 0 of this function f of x is 0, even though the value of the function is not at 0 is not 0. The limit, in the limit as x approaches 0, either from the left or the right, I get 0. So the limit as x approaches 0 is 0. All right, I'll meet you in the next video.